Hi guys, this is A2 Chemistry, Organic Chemistry, and we are looking at organic synthesis. Question 13. Benzocaine is used as a local anesthetic. It can be synthesized from 4-nitromethylbenzene by the route shown. So in step 1, the nitro group is reduced to the amine group. In step 2, the amine group reacts with an acyl chloride to produce an amide. In step 3, the CH3 group is oxidized to COOH. In step 4, the amide group is converted into amine again. That means it undergoes acid hydrolysis. And in step 5, the carboxyl group reacts with CH3CH2 to form an ester, which means CH3CH2OH. It reacts with ethanol to form benzocaine. Give the systematic name of compound W. So compound W is benzoic acid and it has got an amino group present as well. So the preference would be given to the benzoic acid name. So this would be called 4-amino benzoic acid. Suggest the reagent and conditions for steps 1 to 5. In step 1, NO2 is converted into NH2. So here we have tin plus concentrated HCl reacting to produce uh, the 4-methyl phenylamine, which is the product of step 1. In step 2, the NH2 group is converted into an amide CH3CO. So the reactant is CH3COCl. That is the reactant and it reacts with amine to form the amide. There are no additional conditions present. In step 3, we have got the CH3 group converting into COOH. So we have a reaction taking place with acidified KMNO4 plus heat. And in this way, the methyl benzene's methyl group will be converted into the carboxylic acid group. It will convert into benzoic acid. In step 4, we have the conversion of the amide into amine because it undergoes hydrolysis, which is known as acid hydrolysis. So we have HCl plus H2O plus heat under reflux to produce the phenylamine again. And in step 5, we have conversion of the carboxylic group into an ester and the reaction with ethanol occurs. So we have presence of ethanol, CH3, CH2OH. We have a catalyst, H2SO4, and we need to heat under reflux in order to bring about this reaction. Question 14. Complete the following table to show the structures of the products formed and the type of reaction occurring when serotonin, the structure is shown above, reacts with the 4 reagents in separate reactions. So with sodium, so the reaction with sodium would mean that it will react with the OH group and there is only one OH group present, and this would be a redox reaction because sodium will oxidize and hydrogen gas will be produced, so H positive ions will reduce. So the product would contain the serotonin molecule as it is drawn except for the OH group, which will be converted into O minus and Na plus. Rest of the molecule remains as it is. So this is the rest of the molecule and the type of reaction is redox. Next, with excess Br2. With excess Br2, the and it's aqueous. With excess Br2 aqueous, we would have electrophilic substitution taking place on the phenol part of serotonin, that is the one with the OH group attached to it. So what we would have would be the Br atoms are substituting hydrogen atoms on both sides of the OH groups. The carbon atoms adjacent to it will have Br placed on them in place of hydrogen, and the rest of the molecule stays as it is. And this reaction is called electrophilic substitution. Next, the reaction is with excess CH3COCl, and for simplicity and ease, the molecule of serotonin is drawn on the left. So now the reaction of acyl chloride will be with phenol as well as with the amine group. So two of the groups would be reacting. So we would have the rest of the molecule as it is, and the NH2 group converting into NH group with C double bond O and CH3 attached to the NH2 group to form an imide bond, and with the OH group's oxygen atom as it is, this being attached to C double bond O single bond CH3 to form the ester bond. So since this is formation of ester and amide, both of them are formed through condensation reaction. So the type of reaction would be condensation. Next, with excess hydrogen and platinum as catalyst, we would have the benzene ring being hydrogenated and the ring being removed, and the double bond also being hydrogenated and the double bond being converted into a single bond. So here we would have the benzene ring without the ring, the OH group present in its position only, the double bond in the five-membered ring with nitrogen in it converted into a single bond, and the rest of the molecule remaining as it is. So this is the product when excess of hydrogen is reacted with platinum as a catalyst, and this reaction is known as hydrogenation. Question 15. Cumin is a spice used to flavor food. The compounds responsible for its flavor are cuminaldehyde and cuminyl alcohol. Cumin alcohol can be synthesized from benzene by the following route. So benzene is converted into an alkyl benzene, which is then converted into an aromatic ketone, which is then reduced, or rather, it is converted into a carboxylic acid, and then it's a ketone that is converted into carboxylic acid. Okay. Okay, so alkaline aqueous iodine would react with it. And then we would have presence of or other formation of cuminyl alcohol. Suggest reagents and conditions for steps 1 to 4. So step 1 will be electrophilic substitution, in which we will have CH3 twice CHCl reacting along with the catalyst AlCl3 to produce the product of step 1. In step 2, we would have CH3COCl reacting with the catalyst AlCl3 and the product of step 1 to form the product of step 2. In step 3, we would have NaOH and iodine, alkaline aqueous iodine, reacting, and when the product has formed, then the product will be converted into the carboxylic acid by reacting with HCl aqueous. So followed by HCl aqueous. If HCl aqueous is not added, it wouldn't be COOH, it would be COO minus Na plus that would have been formed because NaOH is part of the reaction. And in step 4, the COOH is reduced into CH2OH, a primary alcohol, which is only possible when we reduce the carboxylic acid with LiAlH4 along with dry ether. This would reduce the carboxylic acid into a primary alcohol. Next, we have name the mechanism for steps 2 and state the type of reaction in step 4. Step 2 is electrophilic substitution, and the type of reaction in step 4 is reduction. Question 16. A student suggested that phenol can be prepared from benzene by the method shown. So benzene is converted into nitrobenzene, which is converted into phenylamine, which is converted into benzene diazonium chloride in K, and which is converted into phenol. So suggest reagents and conditions for each of the following steps. Step 1 would be HNO3 plus H2SO4 plus temperature between 50 to 55 degrees Celsius in order to produce nitrobenzene. In step 2, we would have reduction of nitro group into amine group. So that would require 10 plus concentrated HCl. And in step 4, we would have the benzene diazonium chloride being converted into a phenol. So that is hydrolysis. So we would need water plus heat that would produce the phenol. And in order to complete the organic synthesis pathway, we draw the structure of compound K, which is benzene diazonium chloride. So it's N triple bond N positive and Cl negative. Deduce the structure of for K and draw its structural formula in the box already done. Name the mechanism for step 1. The mechanism is called electrophilic substitution, and write an equation for step 2. Use square brackets H for the reducing agent in this equation. So step 2 would mean write an equation. So C6H5NO2 upon reduction, and we would need 6 hydrogen here in the presence of tin and concentrated HCl. It would produce C6H5NH2, and it would also produce 2 moles of water. So that is the equation for the reduction of nitrobenzene into phenylamine. Question 17. 2-hydroxypropanoic acid can be synthesized in 4 steps from ethanoic acid. So ethanoic acid is converted into acyl chloride. Acyl chloride undergoes substitution to form nitrile. The nitrile is hydrolyzed into carboxylic acid. The ketone portion of the molecule is reduced into secondary alcohol, which is 2-hydroxypropanoic acid. Suggest a reagent for step 2. Step 2 is conversion of Cl into Cn, which means we need KCN or NaCN, either potassium cyanide or sodium cyanide. Suggest reagents and conditions for steps 1 and 4. Step 1, the reagent is PCl5, or it could be PCl3 plus warm, or it could be SOCl2. Any one of these reagents and conditions will produce the product of step 1. And for step 4, we have reduction of a ketone to a secondary alcohol. So we would need NaBH4. And the reason we would need NaBH4 is because if we use LiAlH4, which is a harsher reducing agent, it would convert the carboxylic acid into a primary alcohol as well. And we do not need to do that. We only need to convert the ketone into a secondary alcohol, which can be carried out using a milder reducing condition of NaBH4. Compound R can be used in the synthesis of compound T as shown. So compound R produces compound S, in which we have loss of the chlorine atom, and the product S is converted into product T by reducing it with LiAlH4. So compound R is reacting on its own. So if you look at R carefully, we have an acyl chloride group and an amine group present in R. So the amine group would react with the acyl chloride group to form an amide group. So the product S, they've asked us to suggest the structures for SNT and draw them in the boxes above. So we've got a C double bond O group bonded to an NH group. This is this and this part of the molecule. So if they are bonded together, the remaining molecule would be the NH2 attached to a carbon atom, which is bonded to a CH3 group and also a hydrogen atom. And we have got two other CH2 groups in between these. So CH2 and CH2. So this is the structure of compound S when the compound R undergoes a condensation reaction to form a cyclic compound. So CH2 here and a CH2 here. So this is the molecule of S. And when S undergoes reduction, so reduction of an amide produces an amine. So this results in the production of CH2, CH2, CH, the CH3 group remains, the NH group remains, and the C double bond O becomes CH2. So this is product T. Name the type of reaction for steps 1 and 2. So step 1 was the acyl chloride group reacting with the amine group to form an amide group. So this reaction is called condensation. And step 2 was the reaction with LiLH4, which results in the amide group converting into an amine group, which is known as reduction. Compound R can be polymerized. The compound R is drawn for simplicity on the right. Draw a section of this polymer showing two repeat units. So the polymer would be a polyamide because one end of this molecule has an NH2 group and the other end has a COCl group. So if we draw the polymer of this compound, so it would be a CH2, then we would have a CH2 molecule, and then we would have a C double bond O molecule. Then this CH will be attached to a CH3 on one side, H on one side, and NH on one side. So this is one repeat unit, and this will be bonded to another repeat unit, which will start with NH, then go on to CH3 and H, then with two CH2 groups present in the chain, and the second repeat unit would end with a C double bond O group. And we can place the two repeat units in a box, showing that these are two repeat units of this polymer, and we can also label the amide bond present. So this is the amide bond, which is also the reason that this compound polymerizes, because an amide bond can form between the two acyl chloride and the amine group in the molecule of R. This is the amide bond or the amide linkage. So this is the polymer showing two repeat units of compound R.